Hello, my fellow students. Back to lesson 2. This is geography. This is syllabus coverage side. If you need KCSE revision, it is also available. You can watch my videos, listen to them, take some notes as you revise for your KCSE. So this is lesson 2. We are going to proceed from where we left. This video is going to take 1 hour. Each lesson is 1 hour. So we are going to start from the structure of the earth. As you can see on the screen, kindly take some time to analyze the diagram on the screen. You have the atmosphere and ionosphere. Those are the external structures, the external structure of the earth. Then you have Ciel and Sima. It is also called crust. They are lithosphere, so it is crust or lithosphere. Then you have the upper mantle and lower mantle, and they constitute mantle or called asthenosphere. Then you have inner core and outer core, it is core, the barysphere. Then you have Mohorovic discontinuity and Quaternberg discontinuity. Kindly take some look on the diagram because the diagram is very important. It is being set in KCSE. We have seen from the past papers that structure is being set. Internal exams, that structure is being set. Joint, post-mock, pre-mock, that structure is being set in geography. So kindly take some time to look at that structure, the parts, and also take notes of the discontinuity, core, lithosphere, asthenosphere. So kindly take some time to look at that structure. So let's start from the internal structure of the earth. So the evidence used to study the earth's interior are, you have mining, drilling, excavation or quarrying. Let's start with crust or lithosphere. So crust, it is the outermost layer of the earth. It is made up of soils and other loose deposits of sand. The dominant rocks are granites. It extends from 0 to 50 kilometers. Then it has two layers. So that is crust. Then let's talk about Ciel. So Ciel, also called continental crust, it is made up of light colored rocks. It is called Ciel because it is made up of silica and aluminium. Remember, we have said that crust is made up of two layers, and the layers are Ciel. The first layer is Ciel, which is also called continental crust. It is made up of light colored rocks. It is called Ciel because it is made up of silica and aluminium. Number 2 is Sima, also called oceanic crust, made up of basalt soap. It is made up of basaltic rocks which are brittle. It is made up of basaltic rocks which are brittle. It is called Sima because it is made up of silica, magnesium and iron. Then we move to another part of the internal structure, which is Mohorovic discontinuity, also called MOHO. It is the definite zone of discontinuity between the crust and the mantle. It is the definite zone of discontinuity between the crust and the mantle. Was discovered by Dr. Andrija Mohorovic in 1909. P is the mantle or asthenosphere or mantle. So this is a layer lying between the crust and the core. It is made up of iron and magnesium. has two layers. So has two layers. You have the upper mantle. Upper mantle rocks are more elastic than those of Sima. Then temperature is about 1000 degrees Celsius. Then you have lower mantle. Rocks are like very viscous fluid. Rocks are like very viscous liquid. Temperature ranges between 1000 degrees Celsius to 3000 degrees Celsius. Then why is the interior of Earth very hot? Why is the interior of Earth very hot? Why is the interior of the Earth very hot? So this is a question that can be set in exam. It is set, it has been set, and they will continue to set it in your exam. So why is the interior of the Earth very hot? The first one, due to radioactive decay causing most of the heating. So the first one is due to radioactive decay causing most of the heating. Another one is due to great pressure as a result of overlying crustal materials. Due to great pressure as a result of overlying crustal materials. Then the last one, the original heat resulting from slow cooling of the materials which were pulled off the sun. The original heat resulting from slow cooling of the materials which were pulled off the sun. So those are the reasons why the interior of the Earth is very hot. Then we have Gutenberg discontinuity. So this is a definite zone of discontinuity between the mantle and the core. This is a definite zone of discontinuity between the mantle and the core. In the mantle and the core, as you have seen in the diagram I showed you above. So the Gutenberg discontinuity is a definite zone between the mantle and the core. Another internal structure of the Earth is core. Somebody can also call barysphere. Somebody can also say centrosphere. So core, the innermost or central layer of the Earth. So core is the innermost or central layer of the Earth. Then it has two layers. We have the outer one and the inner core. So outer core is composed of very dense rocks made up of nickel and iron. Temperature are up to 3700 degrees Celsius. Inner core is a solid mass of mainly iron. Temperatures are estimated to be 4500 degrees Celsius to 5000 degrees Celsius. Those are the internal structure of the Earth. Let's move to the external structure of the Earth. So external structure of the Earth are made of, the first one is the atmosphere. So atmosphere, layer of gases. Atmosphere is layer of gases surrounding the Earth. The Earth revolves within it because it is held onto it by gravity. It is about 330 kilometers thick. What are the composition of the atmosphere? Another question which is very important. Composition of atmosphere. Gases exist as a mixture. Gases exist as a mixture. Smoke particles, you have dust particles, and you have water vapor. So those are the composition of atmosphere. Gases exist as a mixture, smoke particles, dust particles, and you have water vapor. The structure of the atmosphere. What is the structure of the atmosphere? Atmosphere is divided into 4 layers or zones. Namely, the first one is troposphere. So we are going to look at the troposphere as the structure, as one of the layers in the atmosphere. So troposphere, lowest layer of the atmosphere. So troposphere is the lowest layer of the atmosphere. It contains 90% of water vapor. Rainfall is got from it. Temperature decreases with increase in altitude. Air is turbulent due to mixing of air, contains dust particles. there is a zone of transition between troposphere and stratosphere called tropopause. So that is all about tropopause, troposphere as one of the layers in the atmosphere. The other one is number 2. We are going to talk about stratosphere or ozonosphere. So stratosphere is also called ozonosphere. So it is a layer existing to troposphere as layers. Lower isothermal layer in which temperature is constant. Upper layer of the temperature inversion in which temperature increases with increasing altitude. As ozone layer, which absorbs harmful ultraviolet radiation. So stratosphere has ozone layer which absorbs harmful ultraviolet radiation. Then you have air is calm, so it is used by the passenger jets. Limited amount of water. Stratosphere has limited amount of water. There is a zone of transition between stratosphere and mesosphere called stratopause. Number 3, we have mesosphere. It is the middle layer of the atmosphere. Temperature decreases with increasing altitude. There is a zone of transition between mesosphere and thermosphere called mesopause, which is an inversion layer. Number 4, we are going to talk about thermosphere or ionosphere. So high radiation is present in this layer. The pressure is very low. Gases and molecules in this layer exist as ions due to high radiation. Has no definite top but merges gradually into the outermost part of the atmosphere called exosphere. Exosphere consists of rare gases like hydrogen and helium. Beyond the atmosphere, there is the outer space. The outer space is the universe beyond the atmosphere in which other planets and stars exist. The next thing that is supposed to know are the significance of atmosphere. What are the significance of atmosphere? Animals and plants breathe in from it oxygen for respiration. Animals and plants breathe in from it oxygen for respiration. Plants use carbon dioxide or carbon dioxide from it for photosynthesis. Plants use carbon dioxide from it for photosynthesis. Water vapor in the atmosphere condenses to form clouds which give us rain. Water vapor in the atmosphere condenses to form clouds which give us rain. Ozone layer in the stratosphere shields us from ultraviolet radiation which may cause cancer. Ozone layer in the stratosphere shields us from the ultraviolet radiation which may cause cancer. So that's why we are talking about the skin cancer here. Then carbon dioxide and methane in the atmosphere cause global warming through the greenhouse effect. So carbon dioxide and methane in the atmosphere cause global warming through the greenhouse effect. So those are the significance of atmosphere. So if you're told in exam to give significance, or you're told to highlight significance of atmosphere, please do so by simply giving the answers you can see on the screen or you have heard. So we are going to talk about part B. We are going to talk about the hydrosphere. Remember, we are talking about the external Earth structure. The first one we talked about, we have just concluded talking about atmosphere. We are given even the importance or significance of atmosphere. The next one we are going to talk about is hydrosphere. Part of the Earth's surface covered by water masses, e.g. oceans, seas, lakes, rivers, and even underground water. hydrosphere. From the name, hydro means water. It comprises of 73% of the Earth's surface area. It comprises of 73% of the Earth's surface area. The next one, the atmosphere and hydrosphere are related in that atmospheric gases penetrate to the ocean depth in the solution form. So how is the atmosphere and hydrosphere related? The relationship between hydrosphere and atmosphere is that the atmospheric gases penetrate to the ocean depth in the solution form. The lower atmosphere, hydrosphere, and the upper part of the Earth's crust are called biosphere, meaning the sphere of the Earth in which organic life exists. Biosphere, bio from the word bio, meaning the sphere of the Earth in which organic life lives. So that is the end of the structure of the Earth. We are going to talk about weather. Weather is very simple. So what is weather? What is weather? So weather is just daily atmospheric condition of a place at a particular time. So daily atmospheric conditions of a place at a particular time. So elements of weather. What are elements of weather? In exam, you'll be told to explain 4 elements of weather. State 4 elements of weather. So the first one is temperature, humidity, precipitation, atmospheric pressure, wind, sunshine, then you have cloud cover. So those are the elements of weather. There are 7. You have temperature, humidity, precipitation, atmospheric pressure, wind, sunshine, and cloud cover. We'll be seeing that we are going to explain them further in details as we proceed with the class. A weather station. What is a weather station? What is a weather station? It is a place where observation, measuring, and recording of weather elements is done. Weather station is a place where observation, measuring, and recording of weather elements is done. So what are the factors to be considered when setting or you want to start up a weather station? What are factors that you're supposed to consider? Factors to be taken into account when setting a weather station. What are the factors you're supposed to consider? Number 1, an open place where there is little obstruction of weather elements. An open place where there is little obstruction of weather elements. Number 2, accessible place so that recording can be done easily. Accessible place so that recording can be done easily. A fairly level or gently sloping ground so that it is easy to position weather instruments. A fairly level or gently sloping ground so that it is easy to position weather instruments. Number 4, the place should provide a wide view of the surrounding landscape and the sky. The place should provide a wide view of the surrounding landscape and the sky. Number 5, the site should be free from flooding. The site should be free from flooding. Number 6, the place should have security. So security is a factor that must be considered when setting weather station. The place should have security. Instruments for measuring elements of weather. Instruments for measuring elements of weather. You have thermometer, which measures temperature. You have hygrometer, which measures humidity. You have rain gauge, which measures rainfall. Barometer, which measures air pressure. Sunshine recorder, which measures sunshine duration and intensity. Wind vane measures wind direction. Anemometer measures wind speed. You have evaporimeter, which measures the rate and the amount of evaporation. Let's go to the estimation screen. The estimation screen. So this is the diagram of stabilization screen. As you can see, we have stand, air spaces between the roofs, then you have viewers. So we are going to see the reasons why we have all those. Then it is always painted in white. A white wooden box mounted on 4 legs used to house thermometers and agrometers. So stabilization screen is used to house thermometers and agrometers. The instruments which are found in it are, we have maximum thermometer, you have minimum thermometer, 6 thermometer, then we have agrometer, we have wet bulb and dry bulb. Kindly remember this. ALM instruments found in stabilization screen, there are 4. We have talked about maximum thermometer, minimum thermometer, 6 thermometer, then we have hygrometer, where we are talking about wet bulb and dry bulb thermometer. What are the importance of stabilization screen? Provide shade conditions for accurate temperature reading, ensure safety of thermometers because they are delicate. So those are the importance of stabilization screen. Provide shade conditions for accurate temperature recording and ensuring safety of thermometers because what? Because thermometers are very delicate. Qualifications which makes stabilization screen suitable for its work. What are the things which make stabilization screen suitable for its work? It is painted white. For what? Why is it painted white? It is painted white for little absorption of solar heat energy. It is made up of wood. Why is it made up of wood? Wood is a bad conductor of heat. It is well ventilated. Why is it well ventilated? It is well ventilated to allow easier flow of air inside it. It is raised. Why is it raised? Some meters above the ground. It is raised to prevent contact with terrestrial radiation. As a double roof. Why does it as a double roof? As a double roof, which acts as an insulator to prevent direct heating from the sun. So those are the features that make stabilization screen suitable for its work. These are the features, these are the qualifications that make stabilization screen suitable for its work. I have said they are painted white, the reason I have given. They are made of wood, the reason I have given. They are well ventilated, I have given the reason. Why is it raised? I have also given the reason. Then why does it have a double roof? I have also given a reason for that. Recording and calculating weather conditions. So we have the first one is temperature. What is temperature? Temperature is the degree of hotness of an object or a place. It is measured using 3 types of thermometers. So how do you measure temperature? Temperature is measured using maximum thermometer, you have minimum thermometer, and you have 6 thermometer. So let's start with maximum thermometer. Maximum thermometer, it is used to measure the highest temperature reached in a day. It uses mercury. How does it work? How does maximum thermometer work? How does it work? Or how is it used? Temperature rises, causing mercury to expand. Mercury pushes the index up. When the temperature falls, mercury contracts. The maximum temperature is read from the scale at the lower end of the index. The thermometer is reset by shaking it to force mercury back into the bulb. So that's how we use maximum thermometer. So thermometer is reset by shaking it to force mercury back into the bulb. Then let's talk about minimum thermometer. It is used to record the lowest temperature reached in a day. It uses alcohol. How is it working or how is it used? Temperature falls, causing the alcohol to contract. Alcohol pulls the index down. When temperature rises, alcohol expands and rises in the tube. The index remains where it was pulled. Minimum temperature reading is obtained from the scale at the lower end of the index. Calculating temperatures. How do you calculate temperatures? These are terms you are going to meet in your examination. You'll be given a table with they will be given day or month with some data of temperatures. Then you'll be told to calculate these terms you are going to define here. So if you are told to calculate the due north or daily temperature range, what are you supposed to do? So daily temperature range is just the difference between the maximum and minimum temperature for any one day. Then what is mean daily temperature? Mean daily, mean from the one mean. So we simply it is the average. It is the average of the maximum and the minimum daily temperatures. Mean daily temperature is the average of the maximum and the minimum daily temperatures. What is number 3 is mean monthly temperature. Monthly. So it means monthly. So we are going to get the sum of the monthly temperatures, then we divide by the number of the months provided. Then mean monthly minimum temperature. You have mean monthly minimum temperature. So it is the sum of the minimum temperatures divided by the number of the months. Then you have mean monthly maximum temperature. It is the sum of the maximum temperatures divided by the number of months. Then you have mean annual temperatures. Mean annual means yearly. Annual means yearly. Sum of the mean monthly temperatures divided by the number of divided by 12. Annual means 12. Mean annual temperature range. Mean annual temperature range. Mean annual temperature range. The difference between the highest and the lowest mean monthly temperature in a year. Let's go to rainfall. This is a diagram. So you have that rain gauge. So rain gauge is the instrument used to measure the amount of rainfall in a day. It should be considered of impermeable material. It should be made up of impermeable material which cannot absorb water. From your biology, you know what permeable materials are. So it should be made up of impermeable materials which cannot absorb water. How does a rain gauge work? It is taken to an open place to prevent water from dropping into the funnel. That is the reason why it is taken to an open place. It is sunk into the ground to do what? To prevent evaporation. The funnel is left 30 centimeters above the ground to do what? To prevent splashes of water and runoff. That's why the funnel is placed 30 centimeters above the ground. We have given a reason why it is that. So to prevent splashes of water and runoff. After 12 hours, water is emptied into the measuring cylinder. The reading of the amount of rainfall is got from the measuring cylinder in millimeters. The figures represents the millimeters of water falling on each square meter of the ground. It could be used to measure snowfall by melting it below the reading before the reading are gotten. Calculating rainfall. You have monthly rainfall total. So this is just the sum of rainfall recorded in a month. Annual rainfall total. It is the sum of monthly rainfall totals for 12 months. Annual rainfall total. You have mean monthly rainfall. It is the sum of rainfall totals for a particular month over several years divided by the number of the years of observation. Then you have mean annual rainfall, the sum of mean monthly rainfall for 12 months of a year. Then let's move to sunshine. So this is the diagram. Sunshine. So the duration of a sunshine is measured using a Campbell stroke sunshine recorder. So this diagram here is a Campbell stroke sunshine recorder. So this is a sunshine recorder. We have metal frame we have spherical lens, we have sensitized paper. How does it work? How does this sunshine recorder work? So the first one, we are going to talk about the spherical lens. So spherical lens focuses light on the sensitized paper. So spherical lens, it focuses light on the sensitized paper. The paper burns when the sun is shining. The paper burns when the sun is shining. The total hours of sunshine is gotten by adding all the burnt section from the calibration on the side of the sensitized paper. The sensitized paper is changed every day. We are going to humidity. What is humidity? Humidity is the condition of atmosphere with reference to its water content. Humidity is the condition of atmosphere with reference to its water content. It is measured with hygrometer or psychrometer, which consists of wet and dry bulb thermometers kept in the station screen. Dry bulb thermometer is a thermometer covered with muslin bag immersed in water, while dry bulb thermometer has no muslin bag. How does it work? How it works? When air is dry, there is a lot of evaporation from the muslin bag. Evaporation cools the bulb of thermometer, resulting in a low temperature reading. When humidity is high, there is a little evaporation from the muslin bag. The wet bulb thermometer is cooled at a lower rate, and both thermometers show almost the same temperature reading. The difference in reading between the two thermometers is used to determine the relative humidity. So we have wet bulb thermometer and you have dry bulb thermometer, as you can see in the diagram. How do we interpret hygrometer reading? How do we interpret hygrometer reading? When the two readings are the same, relative humidity is 100. That is, the air is saturated. If the difference is small, humidity is high. If the difference is big or huge, humidity is very slow. Calculating humidity. Absolute humidity. This is the actual amount of water vapor in a given volume of air can hold. It is expressed in grams per cubic meter. Grams per cubic meter. Specific humidity. It is the mass of water vapor in a given mass of air. It is expressed in grams per kilometer. Relative humidity is the ratio between the absolute humidity and the maximum amount of water the air can hold, expressed in percentage. Let's move to wind. Wind direction. So wind direction is determined using a wind vane. How does a wind vane work? As the wind blows, the arrow swings. The arrow points in the opposite direction of the wind flow. Remember that the arrow points in the opposite direction of the wind flow. The direction is read from the cardinal compasses points. The arrow will point in the direction from which the wind is blowing. For instance, if it points south, the wind is blowing from south north. You have windsock. This is the windsock. It is used to indicate the general direction of a wind flow, not kept in a weather station. Why? Because it does not give the accurate direction of a wind flow. If it is kept in a weather station, it will not give the accurate direction of the wind flow. Seen near airstrips for the benefits of pilots. So it is seen near airstrips for the benefits of pilots. How does it work? When the wind blows, the bus stretches out in the direction that the wind is blowing. So we are going to wind speed or velocity. Measured using anemometer. How does anemometer work? When wind blows, hemispherical caps rotate. When the wind blows, hemispherical caps rotate. You can see the hemispherical caps. The number of rotations is obtained from the meter on the lower part of the anemometer. So you have the meter here. So the number of rotations is obtained from the meter on the lower part of the anemometer. The units for measuring wind are called knots. We are moving to atmospheric pressure. What is atmospheric pressure? The force exerted by gases in the atmosphere on some areas or body of the Earth's surface. So atmospheric pressure is the force exerted by gases in the atmosphere on some area or body on the Earth's surface. Measured using barometers of 3 types. You have 3 types of barometers. You have mercury, aneroid, and you have 14 barometers. Let's look at the mercury barometer. How does a mercury barometer work? This one you have seen, you have also read this in physics if you are doing physics. This one is there in physics, mercury barometer. So how does mercury barometer works? Air exacts pressure on the mercury in the beaker. The height of a mercury in the tube is proportional to the atmospheric pressure. The height of mercury in the tube is proportional to the atmospheric pressure. The readings are taken in millimeter mercury. It is 760 millimeters mercury at the sea level. Advantage of mercury, it is quite accurate. Disadvantage, it is cumbersome to carry around, can be damaged easily while being carried around. So those are the disadvantages of mercury barometer. We are going to aneroid barometers. Measures changes in the atmospheric pressure. How does aneroid barometers work? It works. How does it work? As airtight compartment. It has airtight compartment. Compartment expands when pressure decreases. It collapses when pressure increases. The movement is transmitted by lever to a pointer on a dial. The readings are in kilometers per cubic centimeters. Evaporation. What is evaporation? The rate and amount of evaporation is measured using a pitch and tank evaporimeters. What is a pitch? So let's start from a pitch evaporimeter. What is a pitch evaporimeter? So this is it. A pitch evaporimeter. This is it. So you have a glass tube, scale, water, steel wire, spring, then you have blotting paper. When there is a lot of sunshine, water evaporates from the blotting paper. The level of water in the glass tube reduces. The rate and amount of evaporation is got by looking at the scale on the outside of the glass tube. The units are in millimeters. Let's talk about tank evaporimeter. Tank, just as the name suggests. So you have a shallow tank, then you have that tank is calibrated. So how does it tank evaporimeter works? The tank with water is put on in the open. Water evaporates when there is a lot of sunshine. Water in the tank reduces. The rate and the amount of evaporation is gotten from the calibrations in the inner side of the tank in millimeters, as you can see in the diagram. Let's move to cloud cover. What is cloud cover? What is cloud cover? Right, you have gotten it right. The amount of cloud cover is observed using the eyes. It is given in octaves. Let's move to weather forecasting. Weather forecasting. So what is forecasting? This is just the prediction of the conditions of the atmosphere for a given place for a certain period. So weather forecasting is the prediction of the condition of the atmosphere for a given place for a certain period. Here are methods of weather forecasting. Methods of weather forecasting. Methods of weather forecasting. Let's start with the traditional methods. Predictions of weather based on traditional methods, based on traditional beliefs and facts. So predictions of weather based on traditional beliefs and facts, and actually they still work up to date. Some communities still use this. In fact, all the communities still use this. Plants shedding leaves indicates period of drought. That is the first one. Safari ants indicate it will rain. Migration of butterflies also indicates it will rain. Croaking of frogs during dry seasons indicate it is going to rain. Flowering of certain plants indicates the onset of rainfall. Changes in the intensity of sunshine indicates it is going to rain. So those are the traditional methods or beliefs and facts that are still in use up to date. Plant shedding leaves indicates the period of drought. Safari ants indicates it will rain. Migration of butterfly also indicates it will rain. Croaking of frogs during dry season indicates it is going to rain. Flowering of certain plants indicates the onset of rainfall. Changes in the intensity of sunshine indicates it is going to rain. Modern methods. What are the modern methods of weather forecasting? Prediction of weather using modern instruments and technology of collecting, transmitting, processing, and analyzing weather data. So these ones you have seen them, you have heard them on the radio, you have seen them on the television. They are modern methods of weather forecasting. So instruments used. What are the instruments used in modern weather forecasting? We have satellites. What are satellites? Satellites are electronic devices which orbit the Earth, which collect, transmit weather data, which is interpreted by computers. Satellites are just electronic devices which orbit the Earth, which collect and transmit weather data, which is interpreted by computers. Number 2, we have radar. What is radar? An instrument used to see cloud formation. Radar is just an instrument used to see cloud formation. Then you have sensors. Sensors or radiosodes. What are sensors or radiosodes? These are instruments fixed on a balloon used to measure atmospheric pressure, temperature, and humidity. Then you have computers. Electronic devices used to store. Computers are just electronic devices which are used to store, analyze, and display weather information. What are some of the importance of weather forecasting or prediction? What are the importance of weather forecasting or prediction? So the first one helps us to be aware of natural calamities related to weather before they occur, to us to take precautionary measures. So helps us to be aware of natural calamities related to weather before they occur. Number 2, guiding tourists on when to visit the national parks. Guiding tourists on when to visit national parks. Number 3, helps farmers to plan activities such as planting, harvesting, etc. Helps farmers to plan their activities such as planting, harvesting, harrowing, so etc. The next one, ensures air and water transport is carried out safely. Ensures air and water transport is carried out safely. Weather forecasting also helps sporting people to plan their training and competition schedules. Helps sporting people to plan their training and competition schedules. Next one, helps people to plan many other activities such as mining, electricity generation, holiday events. Then the last one, helps fishing communities to plan their activities. Weather forecasting helps fishing communities to plan their activities. So that is the advantage. Those are the advantages of weather forecasting. What are some of the factors affecting weather forecasting? Number 1, lack of skilled manpower due to limited training facilities. That is a factor that affects weather forecasting. Lack of skilled manpower due to limited training facilities. Number 2, lack of modern equipment leading to wrong forecasts. Number 2 is natural calamities such as earthquakes and storms. Number 4, extreme weather conditions which may damage or displace instruments. Number 5, use of faulty instruments. So faulty instruments here simply means damaged instruments or instruments that are not set accurately. They give you faulty results or wrong results. Then another factor which is very common is human error. Then poor setting of instruments. So those are some of the factors that affect weather forecasting. Factors influencing weather. What are some of the factors that influence weather? Factors influencing weather. We have temperature as one of them. Then under temperature, we have some factors that influence temperature. So factors influencing temperature. You have number 1, we are going to talk about altitude. What is altitude? Altitude is just height above the sea level. So we say temperature decreases with increase in height due to air at a higher altitude being thinner, and hence there is less particles. Temperature decreases with increase in height due to air at a higher altitude being thinner, and hence there is less particles, e.g. gases, dust, smoke, and water vapor to store heat, so it's rapidly lost to the outer space. Number 2, latitude. So this is the distance from the equator. So latitude is just the distance from the equator. So temperature decreases with increase in latitude. Then you can explain it like this. Places near equator experience high temperature due to the rays of the sun traveling a shorter distance, facing less interference from atmospheric conditions, hence more solar energy reaches the Earth's surface. Also, the rays of the sun strike the Earth at the right angles, hence the solar energy is concentrated over a small area. At higher latitudes, the rays of the sun travel a longer distance facing more interference from atmospheric conditions, and less solar energy reaches the Earth's surface. Also, the rays of the sun strike the Earth at an acute angle, and solar energy is spread over a large area. Number 3, aspect. What is aspect? Aspect is the direction of slope. Aspect is just direction of slope. At a higher latitude slope facing the equator, the higher temperature because they face the sun, while those facing the poles have a lower temperature because they face away from the sun. Number 4, we talk about wind. What is wind? Wind is a moving air. Wind transfer heat from one place to another. When they blow from cool areas, they take the cooling effect to the areas they blow over, and when they blow from warm areas, they take warming influence to the places they blow over. Number 5, remember we are talking about factors affecting temperature. Factors influencing temperature. Number 5, we are going to talk about distance from a large water body. Areas near a large water body experiences lower temperature during the hot seasons and high temperature during the cool seasons due to sea breeze, warm breeze, and cold oceans current and wind blowing over water, which could be either warmer or cooler than the adjacent land. So that is distance from a large water body. Number 6, we have cloud cover. Cloud reduce the amount of solar energy reaching the surface by absorbing, scattering, and reflecting solar radiation. The next point, where there are clear skies during the day, the temperature is higher due to the Earth receiving maximum solar insolation. During the clear nights, there are very low temperatures due to a lot of torrential radiation being lost to the outer space. Cloudy nights, on the other hand, are warmer due to clouds radiating to the Earth heat and absorbed during the day. The length of the day as a factor influencing temperature. The longer the period of a solar insolation, the greater the quantity of radiation a place receives, and hence more the heat that will be generated by the Earth, and vice versa is true. That is how the length of the day affects temperature. Solar altitude. At equinox, remember we talked about equinox in our first class. At equinox, when the Earth is farthest from the sun, the temperature of the Earth is lower due to less solar radiation reaching the Earth's surface due to traveling a longer distance, and hence facing great interference from atmospheric conditions. At solstice, the Earth receives more solar energy due to traveling a shorter distance and hence facing less interference from atmospheric conditions. If you don't know what equinox is and solstice is, please refer to the first lesson, first class. I said very categorically when I was teaching that you're supposed to take a keen note of what equinox is. If you don't know what equinox is, kindly go to lesson 1. It is explained there. Number 9, solar input. Sometimes the sun gives more heat due to reactions being violent, causing temperature on the earth to be high. When it gives out less heat, the temperature of the earth is lower. Number 10 is surface conditions. Light surfaces, e.g. smooth surfaces, reflect sunlight, and hence less solar energy reaches the Earth's surface. Dark or irregular surfaces, such as the vegetation, absorbs more heat, leading to higher surface temperatures. Let's move to humidity. Humidity. Factors influencing humidity. Factors influencing humidity. We are going to talk about the first one is temperature. What are the factors influencing humidity? The first one is temperature. I can see it is 1 hour, so let's meet in the third lesson from humidity. Have a nice time. This is Teacher Victor. Kindly feel free to contact me, reach me, or you can put a suggestion or write a suggestion in a comment section. I will answer you directly. I will also be sharing my number. If in case you have any question, kindly text me, WhatsApp me, call me. Have a nice time as we meet in the third lesson.